Welcome to Frederick's Garage, your destination for oxidation, perforation, restoration, and the 1954 Bel Airror. In this video, we're going to fabricate and attach a lip to the inner wheel well repair. We're going to figure out drain holes for the fender drop-offs or the trunk drop-offs, and we're going to try a chemical solution to bringing back a rusty piece of hardware that the fender skirts mouth with. So stay tuned, see what you think. Let me recap the strategy here for a moment. This has spanned a number of videos, so I guess it doesn't hurt to go back. So the challenge with doing this particular repair is you don't have a lot of flexibility in moving the wheel well wider or narrower because of the fitment of the fender skirt. Also, this car is rusty enough till you take out all the rusty bits, you really lose the structure and shape of the quarter panel itself. So to that end, I've decided to do it in two halves. In other words, fit the back and then fit the front before doing any welding, or at least any permanent welding. So to achieve that, I had created this patch first before cutting off the edge of the original quarter panel. That allowed me to maintain this line. And in the last video, or several videos, I've fine-tuned the fitment of these pieces here, which combined with using the piece of trim, sorry, this isn't the exact piece of trim, but it's one off of a similar car. So you can see that we've got, the appropriate shape in this dimension. And of course, the pieces that are on so far are all held in with screws and clecos. So the point or the goal, that's why these things are just tack welded. The goal is to get these edges and flanges and wraparounds mocked up, but allow these pieces to be removable. That way I can leave the quarter skin in place while I repeat the process on the front portion of the quarter, again, before welding anything. So of course these pieces, when we're ready to go, these will be removed. These spot welds will be connected with additional spot welds. It'll be a continuous bead, if you will. And then we can begin reassembly or reattachment. I understand that you build from the outside in, but then you weld from the inside out, and that's the approach we're taking. So we're getting close to the near final fitment of this rear section, but until we have done the same work for the front section, I'm not willing to commit to welding the rear section. Maybe I'll reverse that thought and put a couple tacks in here or there, but chances are I'll just rely on the screws and the clecos until we're a little farther along with the front. That's my thinking. Cheers. So what I would like to do to prevent this from turning into this is put in a drain, maybe here, maybe here. And I have this steel tubing, and I thought the easiest way might be to drill a hole straight in and then cut a recess and then angle this slightly and just do the finished cutting and grinding once it's welded in. The point is to have maybe half to 2/3 of the diameter at an angle, something like that. Of course, largely recessed and just a little bit of a tunnel showing. The point being that if there's a raised area there, the water isn't likely to get pushed back up in there from the wheel. The wheel, of course, would be spraying right on it. And whether I just need one or two remains to be seen. I believe that this is the lowest point, so any liquid that gets in there would tend to run up to here. So anyway, that's the plan. We'll see what happens. Rethinking this a bit in the spirit of KISS, that is, keep it simple, stupid. What if I were to just put a little slit there and tap in a little valley, a little duct from the back side? For example, little slit here, a little creative beating with a pointed hammer down into a void. Maybe I can make a semi-rounded relief there that will meet the need without any excessive welding or excessive structure, a whole lot of heat and grinding. So let's see. I guess I can always go with the tubing solution if this doesn't pan out, because that's where I'd be making the hole anyway. Let's see. So here's what I ended up with. Nice little dimple right here. So what we did, we cut the slit as indicated and widened the jaws of the vise to span the desired shape, and just beat into the void there with combination of small ball peen and pointed body hammer. And then at the end, use the ball peen as an anvil in the vise, or a dolly in the vise, and use the flat side of the body hammer to just round it out a little bit, take the dimples out. So we'll proceed and do one here, and I think that'll suffice. I think even though that may let a little water in, I think it's better to let it breathe and have a place to drain rather than keep it all boxed up and festering. Well, I guess a sign of maturity is when we can admit our mistakes. And when I set this panel inside the quarter panel, I realized that the lowest point is going to be down here. So having two vents up here really won't do a whole heck of a lot of good. Plus the fact that the rear wheel blows water back there anytime you're driving in the rain. I think these things are going to let more water in than do more harm than good, if you will. So I've pounded them back into shape. I'll just weld them back up, and we'll pretend that didn't happen. I'm going to set up the welding spoon on the back side. Actually, the outside. I'm going to weld it from the inside, and that'll give me a little bit cleaner result. The welding spoon's made out of copper, so the weld won't stick to it. You could use a piece of copper pipe flattened out as well. I just happen to have this tool. Works great if you need to hold it. In this case, though, I need both hands because this piece isn't attached to anything. I'll attach the welding spoon with vice grips. So I've beat the reliefs back in and welded up the slits. Fortunately, I hadn't stretched the metal too badly that it laid down reasonably nice till it's under the car and sanded and painted, and shouldn't be a problem. Anyway, everything's fitting pretty nice down in here, and I have marked where the reinforcement for the fender skirt pin is going to go. And what I'll do is mock. Oh, also I trimmed the top up here, so we're going to mock this up again on the car, see how everything's fitting, and if it's looking good, I'll start to weld a flange on the end of this trunk drop off and on the end of the patch that goes up in here, and then we'll see how everything fits from there. So now we're going to make the flange for the inner fender. That would go on here. And of course down here on the trunk drop off. So let's do some forensics and see just how wide that should be. Here's the cutoff, the original quarter panel. And let's take a look. So it looks like we're going to about there. So maybe 2/3 of the way. So what we have here is our original shape pattern. What I've done is I put a pen mark on there to show about how wide the flange is. Anyway, let me get some scrap metal and mock up a piece. So here we have a piece of 20 gauge sheet metal. This actually came out of a van back in the 70s when they'd cut out the side panels to put in custom windows. In any case, we need to get the paint off of here. And a good way to do that is with one of these fiber discs. It doesn't take away much of the metal like a grindstone would. And for light rust and paint, it works just fine. They don't cost too much money. And I can use a drill. So let's get started, clean this up. So I've trimmed it and tacked it in, just in 3 or 4 spots. I know it's a little too wide, so I'm gonna have to hit it with a grinder to make it fit in the quarter panel a little bit better, maybe grind it down to where you don't see the black line anymore. But it was better to have a little too much than too little, so let's see how we make out. So now that that's ground down, we can see that the width is a little closer to what we had marked before. So let's try the quarter panel on. So I had welded the flange pretty much on the inside of the curve. And what I think I need to do is lay it on the outside of the curve. That is this patch here, because as you can see, there's a little bit of a gap and it's a little too fat as well. So if I put it, well, I'll have to demonstrate, I guess. But in any case, it needs to go up and out a little bit. Let's see how we do. It's fitting nice and tight up here now. Oh, seizure light again. Yeah, and if I use a feeler gauge, I can barely get it between there. I also crimped it in with a tight pair of vice grips, and it seems to move very little. So I'm confident that it's close enough that till I do a plug weld or a rosette weld on the edge of the quarter panel, with vice grips there, it should pull tight enough to weld. So I think we're in pretty good shape. Next, come down here and try and set up this lip and the reinforcement for the fender skirt. So what we're gonna do next is continue our lip, our flange, down to about here. So I think the original flange comes to about here. It's kind of skinny. It's a little skinnier up here than it would be down here. So we'll make a new one that maybe starts up here or at this mark. Looks like pretty much a straight shot to here. Maybe we'll do it in 2 pieces, or maybe I'll cut a crescent shape. It depends how much of a roll is in it as well. So let's start with a cardboard pattern, old cereal box. See how this works out. Gotta get your fiber. Okay, so yeah, it looks like we could do that in 1 piece. Let me mark the back of this. This is real official, real precise here. Need some engineering drawings and CAD CAM work. Let's see, maybe start about there. Yeah, something like that. So mark the back, and then not sure what gauge this cardboard is. All right, yeah, looks pretty good there. Let's try on the other side. Clears in the way a little bit. I think we can mock this up reasonably well. All right, let's missed. Try again. No, let's just fold it over. That might be the best bet. I'm gonna try marking it from this side, maybe. Okay. Back to our kindergarten graphing skills here. Never did get a good grade in art class. Foreshadowing, I suppose. Okay. All right, let's thin that out a little further, because obviously that's way too fat. Okay. So we can replicate this perfectly in metal. It's still going to be too wide, so we'll plan to grind it down once it's tacked into place. And there we go. All right, I'm going to thin it out a little bit up here too. maybe, well, yeah, no sense making it excessively wide. All right. And actually, we might want it a little, let's tweak this a little bit. So that's up there like that. We're probably going to want to tweak this. And this piece would follow this curve a little more closely. Yeah. Yeah. That's what tape is for. All right, on to fine-tuning the pattern with tape and then converting it to metal and then cut metal. So I tried the pattern on under the car, and here it is off of the car on the inside of the quarter, and it looks like it's pretty close. We've captured that curve down to this point, which is about where we would be doing plug welds. So here it allows to plug weld to the flange, and then from here on we'd just be plug welding directly to the trunk drop off. So let's see how we fit over here. I had put a mark somewhere. Ah, there we go. There's the bottom, the end point. So let me mock this up. I have to go back to tripod mode. One moment. So here we are. We'd be welding this on the outside edge like we did the upper piece. So looks like I'll knock some of the earlier piece off because the quarter is a little fatter here, and looks like that'll fit pretty close, and then we'll massage it with the grinder. So we've got a piece of 20 gauge again, and we're gonna have to draw this out twice, one to know how big an area to scuff up, and the other to actually make the cut. So let's do our scuffing. And let's check the back side. Same deal. Let's see here. Yeah, gonna have to clean that up a little bit. All right. A little bit of rust. Looks like we have a few dimples in there too. We'll get a hammer and dolly and dig those out. So much nicer if I can start with now, but your time when you're an object. There you go. Now let's see. And let's see which section. That's near the top. Yeah, I think that'll do. Maybe we'll actually come down here a bit farther just to avoid some of the waffled area. Let's strip this and mark this down here. And that's where we'll plan to take our patch. And there we go. 20 gauge is a little bit more pliable, and of course when I need to push it tight against the fender edge to do a plug weld or a rosette weld, having this a little more compliant would be beneficial. Also, back in the day, I pretty much never had new metal. I was always cutting sections out of roofs and hoods of quarter panels of junk vehicles or wrecked vehicles, and this was the stuff that was available back in the day, so I have the best familiarity with this as well. Let's try this manually, see how we make out. I'll be using the left cut shears. You can really cut any direction you want, but this, the defined direction really controls which way the bent piece goes when you make the cut. So I don't mind that my cut piece is being bent because we are going to curve it around the fender well. So, and it's easy, thin enough and easy enough to straighten out. This is where the Kung Fu grip comes in. I did a little bit of practice TIG welding on this panel, so I will keep away from cutting in the welded section so I don't dull the shears. And there we go. Let's compare that to our target piece. And not too shabby. Just gotta shorten it up a bit. And both sides are clean. You just have to straighten it out a little, and we're ready to go. So I went ahead and I mocked up this piece against the quarter panel itself. So first thing I did, stuck it on the outside here to get the general curve, and then of course marked, of course here's the end point, marked in here where it was a little too fat or the curve wasn't just right, that I would get it to fit in the quarter panel a little closer. Obviously I can grind it once it's mounted to trim it down a little further, but I'm trying to avoid putting the quarter panel on and off 30 times, just working blindly. So one minor issue that doesn't jive, you know, the curvature of this patch here. Let's zoom back out. There we go. So the curvature that this patch has matches the quarter panel, which doesn't exactly match the curvature here. On the other hand, this was brought out to thicken it up to make it meet the quarter panel, you know, in order to add this on here. So before I do any cutting, I think what I'll do is remount the quarter panel and trial fit this piece in there and see if we are in fact too fat with this filler piece or what the real truth is. It's easy to trim, it's less easy to add back on. So let's get the quarter panel mounted, get back under the car, see how things look. Talk about tedious. Well, this is a bit of an oxymoron. The truth lies somewhere in between. So I clamp this in place. It fits good, puts a little twist in it, but it fits good both against the trunk drop off and the under fender well. So what I'll do is I'll put a tack or two in from this side, and then I'll go up and tack it a little more effectively from the outside after removing the quarter. I just love welding upside down on my back, the things we do for our cars. But I got a couple tacks in there, so I'll call that good for now. Let's get this quarter panel back off for the 300th time and get that tacked in a little nicer. So here's what we've got. Got it tacked out here. Had a little bit of a gap and a little bit of an overlap here. So we're gonna fit the quarter panel on one more time and make sure everything's kosher, in which case we'll probably fill that with weld or you know, tacks. We'll put a few tacks in there to firm that up, and then we'll grind this off flush and we'll call it a day. Once again, we're not gonna weld this up fully until such time as we've fitted the front portion of the quarter panel, just in case we need to shift the this portion backwards or maybe even forwards a hair. So we'll have to see. if we didn't have to fit a fender skirt and maintain the opening size so precisely, then we could probably firm this up and even weld on the back portion of the quarter and just move ahead from there. Well, that's the plan. So everything fits pretty good under the car. So what we're gonna do is put a couple of tacks in down here. We'll need to use the welding spoon to fill in the void and better merge those pieces. Here we go. Oh, forgot the gloves. I don't need the gloves so much for the heat, but I keep getting welding splatter on my wedding ring, and that creates a little bit of a marital hassle. That, and it's a little hard on the wristwatch as well. Not my finest work, and of course welding on an edge is always difficult, but we're going to grind this edge down anyway. So let's dress that up, and then we'll tighten that up just a little bit with perhaps a second or third tack. So we've ground that down. Looks pretty nice. Obviously, we're going to fill that eventually, you know, as I said, once we have the whole panel firmed up. But one more quarter panel fitting just to make sure this isn't sticking out too far, and that we can bend the edge in for plug welding with vice grips later on, of course. But we'll check the fit one last time before we consider this done. And at this point, I think we can move on to fitting the front of the quarter shortly. One other thought, this piece and this piece are separate and should be removable, but at the moment they're tacked together right about here, so I'm going to have to run a blade. Actually, it's down here. I'm going to have to run the blade across the new flange that we just put on just to separate these pieces, because once we get everything fitted up, everything's going to come apart, and I'll weld this nicely from the inside and grind everything. And of course, we have to paint and drill holes for the plug welds where applicable, and a lot of prep work in getting the thing ready to weld. But right now, we're still essentially building and doing fitting. So let's try it one more time. So we're going to pull this little skirt retaining tang off of there and clean it up, see if it's heavy enough to reuse or if it's only good for a template. Not much of the original quarter panel lip left there, is there? Let's see how we make out. So I'm curious, in the event that I need to make a new one, what gauge metal to use. So what thickness is this? We take out our measuring tool here, and I suspect it's either 14, which is kind of loose, or 16, which is kind of tight, but the original piece here is somewhat swollen with rust scabs and all. So my guess is it's 16, but taking it one step further, here's a stock piece of 16. I label all my stock so I don't have to measure it continuously. And that feels about right. Whereas over here I have a piece of 14 from a bracket I made some time ago. Pardon the pigeon shit welds. In any case, 14 feels a good bit thicker. Yeah, it's tough to see, but it certainly feels thicker. So if we do need to make a new one, my guess is I make it out of 16. Let's see what the rust chemical does for us first. So here's what a trip on the wire wheel has given us. So let's get this in our chemical, see what we end up with. Using Evaporust and a flat container here. So let's put a little bit in and we'll see how we do. So a little Evaporust in this old container. We'll cover it up just so we don't spill. Hopefully I won't be confused as soup. And we'll check it 12 to 24 hours. Well, here we are, 18 hours later. Let's see how our rust removal is progressing. Open up our container of soup here. And the one-handed dance. There we go. Well, there's some dark residue in the solution. I think maybe we go for 24 hours. I'll get something to flip that over. See how the other side looks. Once again, the one-handed dance. There we go. All right. Well, looks like one corner of it there is cleaning up a little bit, or a little bit better than other parts, but I think more time is needed. Maybe a clean solution too. I don't know if this solution gets saturated. I'll have to study up on that. But for starters, we'll give it another 6 hours. That should bring us to 24, which I think is the end stage of the exposure. Well, here we are at 24 hours. Let's check our soup. Well, the solution looks a lot dirtier. The piece looks somewhat cleaner, not remarkably cleaner. Let me try and flip it over, see how it looks. Yeah, all right, a little bit cleaner. I'll have to do a little Googling, see if I can leave it in longer than this. It's been 24 hours. Don't know what happens if it stays in longer. Does it dissolve or does it continue to get a little less rusty? We'll see. So here's the piece dried off and up close. Looks like we're down to nice clean metal in some spots. Still have some heavier rust in other spots. So I think more time is needed. The solution is still yellowish, does have some residue obviously, so I think it's still viable. So let's give it another overnight. It's been 24 hours now. I'll give it another 10, 12 and see how we make out. So now we're at 48 hours with our piece, our 18 gauge steel piece. Of course, we have fresh stuff for only about 12 hours. And it's looking pretty good. We have some slightly deeper rust where the welds were. You can see the spot welds emerging on this side. So let's give it another 12 or so and see how we make out. I am keeping the container covered and angled like that to keep the piece in the deeper solution. So let's see how we continue to make out. So this is about 2.5 days in. Looks pretty clean, just a little bit of light scale on it. I'm gonna neutralize it with water and then run it on my wire wheel and see how it turns out. I think it's about done. Any remaining rust looks all a bit black and dead. And here we are after the wire wheel, and we're looking pretty nice and shiny. Obviously, there's a little bit of material loss. And I'm not sure if I'm going to reuse it or cut out a new one, but I'd say that's a success. That's pretty doggone nice considering. One more step along the way is to drill out the fender return so we can trial fit the fender skirt. So we're under the driver's side of the car, looking at the trunk drop off, and we're checking out the factory drain, which is this plug. So it's not necessarily in the lowest point of the panel, but it does provide some access for draining things out, blowing things out, maybe even vacuuming things out. So let's pull this plug, see what kind of hole that is, what size hole that is, and see if we might not want to replicate that in our new reproduction trunk drop-offs. So let's get some tools and pull that out. So we've pulled out the plug, and there's what remains of the drilled hole, the factory hole that is. And trying to get a size on it, here's a 15th 30-seconds drill bit, which is 2 sizes smaller than a 1/2 inch. So I think if we do replicate the hole, we'll use this size drill bit. The plug, which is down here, is pretty stiff. Don't know if we're going to reuse it. Try and get some reproduction plugs, and we'll cross that bridge when we come to it, though, when the car's a little closer to assembled and road ready. Also, you can see the rust and dirt that fell off the bottom of the car. When this happens, of course, this is a reminder that your car is far from finished. It's a nice milestone when you're beating on the car or wrenching on the car and rusty flakes aren't coming off. That means you either have a nice clean West Coast car or you're pretty far along with its restoration. So here we've created about the most crude template I've ever done. We've just wrapped a corner around the edge of the trunk drop-off and roughly located the hole, so we have a rough idea of how far back from the corner we would put it on the replacement trunk drop-off. So obviously we'll use the plug to mock up the overall size and location of the hole, because the lower edge here is a little bit different shape and all, but this gives us something to go on to at least approximate the factory configuration. So we're using the driver's side replacement panel for the initial mock-up. So let's put a rough mark where the hole is on the factory panel. So there we go. So now if we take the plug and make sure there's enough room for the plug, there we go. So actually we got to make the hole a little bit higher just to make sure we have enough room for the plug. So what I'll do is I'll put a circle around where the hole should be and find the center and center punch it, and we'll get busy with our drill. So here's a little bit of a hack for finding the center of a hole. What I've done, this vertical line here pretty much is based on the template, how far back to place the hole. Yeah, right about there. And just visually checking on the car, it looks like the hole is kind of midway between this line and the edge here. So that's about where we are. So we have this washer, which is the same diameter as the plug, the outer part of the plug. And so we've set that there inside the circle that we drew on our plug. And we take this dinky washer and put that in the center of the larger washer. It doesn't fit precisely in the center, but at least for me, it allows me to visually detect where the center is a little more precisely. So then, of course, that's where we would use this punch. And of course, I moved it a little bit, but I can move it with the punch and make sure it's centered. And there we go, we've punched it. So that's where we do our hole. And what I do typically, I'll do a pilot with an 1/8 inch drill bit and then move on up to the larger size. I'm not sure if I'll go sequentially or not. I think this stuff's relatively soft. It's thick for sheet metal, but it's soft. So I'll see how I make out with the 1/8 inch, and maybe I'll do one intermediate step. So we'll see. So here we've drilled out the driver's side. 15, 30 seconds hole. And here we've drilled out the passenger side. Same size hole, same process. I just didn't dismount this piece. I drilled from the inside out with the 1/8 inch drill and then went from the outside in with a 15, 30 second drill. The point being I needed to keep this assembled, or I would have had to reassemble it right away to continue on with the quarter panel placement. Cheers. Of course, a series of round holes don't make a perfect oval, so that's where the rat tail file comes in. I had taken lots of measurements along the way before settling on what I consider to be the final position of the trunk drop-off and the rear of the quarter panel. So here's just a quick mapping and reminder of what we found. And of course, I've checked on this along the way as I was mocking it up or finishing the mock-up and all. But let's do a final walkthrough and just double check that the measurements line up. We also have, from way back when, we have these measurements as well, just to confirm the fitment of the quarter panel with respect to the spacing of the trim. So we'll verify some of those as well. With the aid of a couple of vice grip clamps up in the fender lip, we have a respectably fitting fender skirt once again. Of course, this aspect of the quarter panel leaves a little bit to be desired. So that'll be our next move, of course. So to start off, we make sure that we're still level because we will be using the plumb bob. So let's check what I would consider to be the most important measurement of all, and that would be the bevel, or using the bevel gauge and checking the angle of this inner panel. So I've previously set the gauge to match the other side of the car, and you can see that we're spot on there. There's no rocking. Towards the back of the panel, there is a little bit of room for rock on the other side, and same here. There is a slight gap. So I think we're spot on there. So let's check some of the linear measurements. I hate to move the vice grips because I have it just where I want it. In fact, I should probably put in a cleco or screw before I remove them. But in any case, we have 8.5 at the front here, and we have right about 8 inches at the rear, which matches our measurements on the other side. So that's good. Let's see how we do with the plumb bob measurements. That would be the distance from here to the frame, front and back. I think that's a little less critical because these panels might have a little bit more of a return than the original panels. So I'd say as long as we're consistent from side to side on the replaced panels, or the replacement panels, but let's just see. If we take a look from a distance, we look about equivalent from the back of the car. Keep in mind the offset on the right rear wheel, I think, is a little different than the left. I think the right one's tucked in about a 1/4 inch, just wheel design, slightly different offset, even though the wheels look the same on the outside. So in any case, so looking between the frame and the new panel on both sides, it's roughly the same. I'd say the new panel has a little bit of a different arc to it, but with the bump run, you're not going to tell. What I'm really looking at is the shape of the quarter as it drops down. We'll check that angle as well. So in any case, this is all somewhat subjective. I think the real measure is when we have the replacement panel on the left side. Make sure that all that truly looks equivalent. So the plumb bob's a little redundant here. We're really going against the leaf spring, and it's 8.5 if you're on the leaf spring bracket, if you will, and we're 8 3/4 almost if we're on the leaf spring itself. I can't remember exactly how I measured the other side, I can recheck it, but I'd say that's close enough for government work, as they say, because this panel might very well differ somewhat from the other panel. Plus, the other panel is rusty on the bottom, so the precise position of this lip is a little bit nebulous. So I think we're close enough. And again, as long as when we put the replacement panel on the other side, it matches this one, I think that's how we win the game. Let's check the back, though, just for laughs. Okay, so we've got our plumb bob set up on the back here. Also, for the last measurement, I've put this vice grips on the rear just to hold the drop-off panel tight to the quarter panel, because we will be doing plug welds there, the poor man's version of spot welds. So let's see what kind of measurement we come up with here. So it looks like at the back, we're almost exactly 8 inches. And let's check a little farther in. Yeah, there we're almost exactly 8 inches. So as you can see too, this doesn't line up perfectly, so I probably will be grinding off the edge of the trunk drop off to more precisely meet the quarter. But I'm not going to decide any of that until such time as the front of the quarter is affixed, and then we're getting ready to weld up the rear once and for all. So let's check a couple other measurements based on what we had before we took off the original quarter on this side. So I've been able to verify these linear measurements here to here, which is where the quarter kicks down, here to the top of the skirt hole, and then these in here. Of course, you know, for this edge, I had maintained the line of the inner fender well before completely demolishing it. The replacement piece went in before I took off the original quarter, so I'm not surprised that these parts are okay. Here, you may recall earlier in the video, there was some issue with how this fit at the back with the original part of the car, and these measurements all seem to jive, the measurements I'm taking today. So I think we're in pretty good shape with our tentative location. Obviously, as we move to the front of the quarter, we're gonna have some things to consider. These are some measurements I took of the spacing in there on the passenger side before I tore that apart. There was a little bit of structure at one time, so fortunately I captured those measurements back in the day. Did capture similar measurements too here, which I'll verify next. There's one final measurement I'd like to check. That's this, 11.5 inches from the bottom of the trim to the top of the quarter. So let's see what we can do to set up that scenario. Let's take the piece of trim, and there we go. So let's just put a mark there, okay? And let's see how we make out. Vice grips is there on the bottom, so I'm gonna have to be careful to work around that. We've got it about level there, and we're right around 11.5 inches. I know the location of the trim is a little nebulous, and also I didn't indicate which point of this I had taken my original measurement from. I'd assume I had used where the seam of the trim was, which would be right here. So let's try that. This is where good note-taking would prevail. Yeah, so then we're pretty darn close to 11.5, getting the level set. Then one final measurement. I believe earlier in the video, I showed that this panel was about at 90 degrees on both sides. So let's take our protractor here and set that on there, and we're a little bit off from 90 degrees. Let's try here. Yeah, a little bit off actually. So move the camera. Yeah, so according to this, the bottom is kicked in a little farther than the other side. Let's see if the other side's still at 90. This is a good 88. And this is darn near close to 90 right there. Let me just verify again with the other side quickly. So on the other side, we're at 90 right about here. I can't go up to the edge because there's a big rust scab right there, which throws everything off. And then back at the trim seam here, we're at about 89. So let's measure this guy again. And of course, we're measuring at the bottom of the trim, or from the bottom of the trim on the other side. And yeah, that's about 89, not 90. 90 would, I mean, it's so close. And then back here, we're at about 89 also. So while the other panel seems to be like this a little bit, you know, is that a huge difference? I don't think so. Plus, we're not welded up yet either. Yeah, as I go a little closer to where the trim might actually be, this is almost exactly 90. So once again, I think the important thing is that both sides are the same once we have a new panel on. And at this point, I'd declare that close enough. Cheers.